For this problem, I want to make a distinction. The measure of an arc is the same as the angle from the center of the circle, but this is talking about arc length, and that's totally different. So that's something to keep in mind. The arc length is not the same thing as the arc measure. The arc length is that distance, the distance from this point along the curve all the way to that point. So if I want to figure out the arc length, I can't just use this angle, but I need to know the circumference of the circle. So let's look at the circumference formula for a circle. Circumference is going to be equal to 2 times pi times the radius. So the entire distance all the way around, that's what circumference is. So if I wanted to find the entire circumference, then I would just plug in my r. So I plug in 7 here, because that's what I have for my radius. So 2 pi r. Or you can say pi times the diameter, because the diameter is the distance from there to there. And we know that r is the radius. So the entire circumference is going to be, it looks like 14 pi. So that, whatever that unit is, if I multiplied by pi and got an approximation in the calculator, it would be approximately 43.98 units. But I'm not going to worry about that right now. I'm going to leave it in terms of pi. So the entire distance all the way around is 14 pi, but I don't want the entire distance. I only want this distance, and it's a fraction of the entire distance. And I know that in the entire circle there's 360 degrees, but I'm only looking at 46 out of those 360 degrees. So the fraction of the circle that we have is 46 over 360, and I could reduce that. In fact, I will. And that's 23 over 180. So that's how much of the circle we have, and then times the whole entire distance all the way around, and I get times 14 pi. And let's see what it comes out to be. Because all I'm doing is I'm finding this length, because instead of having the whole entire circle, I just have 46 out of the 360 degrees of the circle. Hopefully that makes sense. So I have, if I reduce, 23 180ths of the entire circumference. So here, if I reduce, I'm just going to leave the pi there. And I get 7 and 90, so 7 times 23, that's 161, I think, over 90 pi, and this is going to be units. So the measure of this arc is 161 over 90 pi. And that's going to be approximately, if I just plug it into the calculator, 5.62. So instead of having the whole entire circumference, we have just a little piece of it, and we have 46 360ths of the whole circle, and that comes out to be 5.62, but your answers will be just left in terms of pi. So there we go. Great. To reiterate, all we're doing is finding the entire length around the circle and then taking some fraction of it. And just multiply. The next example is going to use the same circle, except we're going to find area in the same exact way. So we have the same circle, and it says find the area of the sector. So the sector is just the piece of the circle. And again, we're going to, instead of, well, actually, just like we did here, we found the entire circumference and multiplied it by some fraction of the circle. And here we have the same thing. So we're going to do 46 360ths, because 360 is the whole entire circle. And we're going to multiply it by the area. So I need to have my area formula for a circle. And that's just pi r squared, where r is the radius. So that's going to be, for us, pi times 49. And I'm going to write that as 49 pi. And then I just multiply 49 pi. That's going to be in the top. And let's see if I can reduce. Well, I know I can have 23 over 180 and times 49 pi, and I don't think that reduces. So I get 1,127 pi over 180. So that's a lot. I'm going to approximate some stuff here. So 49 pi, that's going to be approximately 153.94 square units because it's area. And then so this should be smaller. And it is. This is approximately 19.67 square units. So there we have it. That's the area. I mean, your answers will be a little bit nicer, but that's the area of the sector. It's just a fraction of the whole entire area of the circle. And we're using the area of a circle formula and the circumference of a circle. So there you go. Great.